Alrighty, so today we're going to write some more definitions. Well, you're going to write some more definitions. And we're going to talk about these crazy things called angles and how they relate to each other. A lot of information today, but shouldn't take tremendously long time, depending on how good you are at writing definitions. So, step number one, please define that picture, which is called a ray. So write your own definition, then check with your group and see if the group can come up with a consensus. You have 2 minutes, go. Like this? Okay, good. What do you got? I went, oh, that's pretty. What is it? All right, what do we got? Okay. I still hate it. Are you selling your headers? I'm just kidding. What's the going rate for a geometry header? What's the going rate for a geometry header? What's the charge? Oh, very nice. Cool.
I said, well,
All right, what kind of trouble you go
Parker
through?
doesn't believe me that I've done four plays with JJ sitting on top. I said a line that starts on the end. But they won.
All right, here we go. Julia, what do you got? Shh. Quiet, please. Go.
A line that travels in only one direction.
Oh, it's not bad. Isn't that almost verbatim what you said too? Yeah. Is it a line though?
Yeah.
Well, what would, when we go back a couple days last week, what was a line?
In both directions.
Both directions. So is that a line?
No.
No.
Line segment.
What's a line segment?
And only it stops at both sides.
Stops at both sides. Does that stop at both sides?
No.
Okay, so ideally we'd like something in between, right?
Yeah.
All right. The only I love your definition except for one thing. I'm bothered by the word line because that isn't a line. What is it? And don't say it's a ring.
I don't know.
Anybody? No. Okay.
A part of a word?
Love it. Okay. Well done. Okay, so let's review. A line goes on in both directions forever. A line segment is finite. It starts and stops. This is a ray. And now that you've fixed that, could you give us your full definition again? So I can write it on the board.
A part of a line that travels in only one direction.
A part of a line that, oh boy, that travels in only one direction?
Yeah.
Well done. Anybody have a problem with that definition? Anything in that definition that bothers you except for my infantile handwriting? Okay, we're good? Beautiful. So, Lines had no endpoints because they go on forever. Line segments had 2 endpoints. Array has only 1 endpoint. Now, the weird part about array is that a ray starts at an endpoint. I didn't write this. And goes on forever in one direction. I happen to have picked B to be on that ray, but there are an infinite number of points that determine the direction. So I could put a C over here, or a Q over here. Gesundheit. Gesundheit. All of those are the same ray. Now, how do we identify them? Okay, so let's see. When we were talking about a line, we put a line symbol over it. When we were talking about a line segment, we put a line segment symbol over it. So if we're talking about array, we should probably put a... Wow. Really? Are you that bad at pattern recognition? Audrey, thank you. Yeah. Put array over it. Okay. However, when we talked about, like for instance on the quiz, we talked about the line PS was the same thing as the line SP. Those were good to go. Okay, check, check. It doesn't apply that way with rays. So for rays, it's a very careful naming process. You start with the endpoint, you list another point on the ray, and the ray symbol must point to the right. It's just the notation that's been chosen. So why wouldn't this be a name for that ray? Claire?
Is B the endpoint?
Good. Okay. What would this ray look like? It would go from B, continue on through A into infinity. Okay, so no good. Start at A, go through B, continue on forever. Okay, so which one's longer, a ray or a line? Neither, they're the same. They're both infinity, and infinity is infinity. One thing I will say is if I put, let's say, Q back on here, this would be the same as the ray AQ. Those are different names for the same ray. Start at A, pass through Q, continue on forever, which would also include B. Questions? Hot diggity. Did that already. Here's an angle. Go ahead, define an angle. Be careful in the words you use.
What do you guys feel like?
Wait until Jessica's done. Copy off.
Those are lines.
You got focus. You got focus. What is it? Picture one right there. What is that? Put it into pictures. That's a good start. What do we think it's worth?
A line segment with a midpoint at the time.
Okay, so
All lines up. That's right. The angle is like we have two I know, I like that. That's fantastic. That's the measurement of how stable is the degree. We can talk about that. Yeah, that's
Does that.
They push it past the whole thing. But it starts there.
What do we got?
I like it.
Do we need this last part?
I mean, like, you could say that if there are two rays that connect on the endpoint, like,
Can you confirm?
I don't know.
I mean, because aren't you saying if they converge at their endpoints, it's an endpoint, isn't it just, aren't you being redundant? Aren't you saying the same thing over and over again, aren't you repeating yourself?
Yeah.
See the joke? Okay, I like it. So what do we got?
Place where two faces intersect each other.
Horrible. All right, let's go with Sam this time. Sam, what do you got for us?
Two rays that converge on their endpoint.
Two rays that converge on their endpoints. Okay? Any problems with that? Now, there is an important statement in that, and he says that they share an endpoint, or they converge on an endpoint. What we want to eliminate is something like that. Okay. Now, that still forms an angle, but we're going to keep it a little cleaner here and go with this bad boy. Once more, Sam.
Two rays that converge on their endpoints.
Two rays that converge at or on their endpoints? On their endpoints. Oops, points. Perfect. Now, some of you talked about degree measures and all of that fun stuff about the angles, but we'll get to that later. What we want is just a definition of that picture. And we don't care about degrees and how it's measured and all that fun stuff. We'll get to that later. Okay. So, continuing the terminology, when you talk about an angle, you have two parts to that angle. The sides of the angles, or sorry, I should say the rays of those in that angle are called the sides of the angle, and the point where they meet is called a vertex. So B is the vertex. Just to make sure we get our language correct, if you have one of them, you have a vertex. If you have more than one, you have vertices. I don't know why vertex is pluralized vertices, but it is. Okay, two or more. One. It's the corner of the angle, if you will. How are we going to name that angle? Three ways. Now, the reason number one is the preferred method is because 2 and 3 can break down. So let's suppose I put another ray in this picture. I shoot a ray out here, and we put a C on there. The naming method used in number one is still clear. I'm talking about that original angle. However, the naming method for number 2 breaks down because when I say angle B, well, which angle B am I talking about? Am I talking about the original one? Am I talking about this one over here? Or am I talking about that whole big process? The third way, I like using the third way, is I just stick numbers in every angle I'm talking about. Okay, so if I'm talking about angle 1, I put a little 1 down there. If I'm talking about angle 2, I'll stick a 2 in there. This sometimes breaks down also because what if I'm talking about this whole big angle? All right, so the 3 points will always work. However, be careful when you're naming it using 3 points. The middle letter must always be the vertex. Okay, so it doesn't matter if you do ABC or CBA, as long as B is the middle point, which is the vertex. Okay. Initially, you're going to struggle with this a little bit, but it'll become second nature in a couple days, where you won't even have to think about it. All right. 4 types of angles. I have 3 of them pictured. What kind of angle is this? Sarah?
Acute,
Good. What kind of angle is this?
ovate,
And this?
obtuse,
Outstanding. But it says 4 types of angles. What angle is not pictured?
the 180 is the flat one.
The flat one, also known as a...
Flat?
No, it's not called a flat angle.
Oh, I don't know.
There's actually 5 types. We only deal mainly with the 3, but the 4 that I have for you are acute, 0 to 90 degrees. Right? Exactly 90 degrees. How do you know if something is a right angle? You'll be told it's a right angle, you'll be told it's perpendicular, or we've already seen that little box down in the corner. Obtuse. 90 to 180. And then the one you were talking about is a straight angle. A straight angle looks like a line. That would be a straight angle. Okay, let's talk about this whole degree thing. Nate, how do degrees work?
I can't.
You can tell us, we're friends.
I don't know.
Oh, how many degrees in a circle?
360.
Good. So then how do degrees work?
So there's a difficulty, like if every point around a circle,
Mm-hmm.
and maybe you put a degree after, like you solve for a circle, solve for an angle.
You're just rambling, aren't you?
Yeah.
Okay. It's a way for measuring angles. It's how big the angle is open. In this class, for the most part, we're only going to deal with angles from 0 to 180. The reason being is if I open an angle past 180 degrees, it just flips over and becomes another obtuse angle. So we're going to focus on these 4. 360 degrees in a circle. That measures how big the angle is open. And notice the little degree symbol is that little circle up in the upper right-hand corner. Okay. 2 ways to deal with congruency. Just like we dealt with congruency with segments, the same is true with angles. You can either talk about the measures of the angles being the same, 45 degrees is equal to 45 degrees, or you can talk about the angles being congruent. I forgot. Ryan, what does congruent mean?
They're the same angle.
Not angles in particular, just what does congruent mean?
They're the same,
Same what?
like the same values, and I'm forgetting.
You got half of it.
Yeah, I have, and
So values would be size, same size, and
I'm
same shape.
yes, yeah.
Okay. So if I pick up this angle CAT and spin it around, it will lay exactly on top of angle DOG. Most of the time we'll use the second one, that the angles are congruent. Same shape, same size. And if you keep that in mind, then things like a 45-degree angle being equal to a 45-degree angle should make perfect sense. Am I going too fast, or are we good? It makes no sense to shake your head yes in that one, because there were 2 options. So it's option 1 or 2, not yes. Are the lights on or off? Yes. Am I going too fast, or are we good? Okay, I'll just continue to talk to myself then. Angle bisector. What's a bisector do? Martha, what's a bisector do? Bi meaning two. Sect means
Cut.
to cut. So what's a bisector do, Martha? Let's back up. Bi means
Two.
two. Sect means
Cut.
cut. So what does a bisector do?
Cut two.
There you go. Cut into two. Not only into two, but into two equal parts, right? So what would an angle bisector do, Martha?
Cut angles.
Hot diggity. There's a picture of one. Commonly, an angle bisector is a ray. It doesn't have to be. It can be a segment. It can be a line. But it's some object that divides another angle into two equal parts. Notice the little arcy things in there. Two arcs matches two arcs. Therefore, those angles are congruent. Two congruent angles. Okay, so we transition from, well, let's go all the way back to this guy. Whoops, this one. 4 types of angles. That's one angle. And that one angle can be 4 types. Acute, right, obtuse, or straight. Now we're going to start pairing up the angles. How many in a pair? How many? 2. Can you have 3 in a pair? No, that would be a trio. So we're talking about pairs. There are 5 of them to start. There's a lot more in the future, but we're gonna go slow today. There's the first one, adjacent. Ashley, what does it mean to be adjacent?
Next to each other.
Perfect, next to each other. So those 2 angles are adjacent. They're next to each other. It would be nice if it were that easy. It's a little bit more complicated. They share a common vertex and a common side. Notice it tells us nothing about the relationship. They're just next to each other. Are we good? Number 2 for pairs of angles. Vertical angles. Now, this bothers me a little bit, but there's not much I can do about it. I don't like their use of the word vertical. Okay, now they being, we're talking like 300 BC. Euclid, the guy that invented all this, used the word vertical. Because for me, vertical is the same thing as when you talk about vertical and horizontal, up and down. It has nothing to do with up and down in this case. It's just a term to describe angles. And they are the angles that are across from each other when 2 lines intersect. Okay, and as it says on the screen, 1 and 3 would be vertical angles. 2 and 4 would be vertical angles. 2 different pairs in that one picture. Corey, just for giggles, what do you think the relationship is between angles 1 and 3, other than the fact that they're vertical angles? Ooh, very nice. Would the same be said about 2 and 4? You think you could prove that? Or are you just going on a gut feeling? So the geometry gods have spoken to you and they have told you vertical angles are equal. That's how the geometry gods sound in my head. I don't know about your head. Okay, all right, we'll go with that. We'll talk about that later. But you're saying that 1 and 3 are equal and 2 and 4 are equal to each other. Interesting. Okay, we'll come back to that. Number 3, linear pair. Now, notice, same picture. Same. All it has to do with is the ones that you choose to match up. So now that we're talking about a linear pair are a pair of angles that are next to each other. They're adjacent. And, oh, hold please. You right, I'll answer the door. Only 3. Okay, you're good? Awesome. I guess just take care of all that. Corey, let's go back to you. So you said that you think 1 and 3 are congruent to each other. That was from this picture. But now we have the same picture. So let me ask you, what do you think the relationship is between angles 1 and 2? Ooh, interesting. Would the same be said for 2 and 3? And 3 and 4? And 4 and 1? Hot diggity. Again, gut feeling or knowledge, previous knowledge? Okay, cool. Why would you say that angles 1 and 2 are equal to 180 degrees? Couldn't have said it better myself. If we go back to this guy, way back here, there you go. Straight line, a straight angle is 180 degrees. Therefore, oh, nope, this one. Therefore, this is going to be 180 degrees, and angle 1 plus angle 2 has to equal 180 degrees. Which also means that angle 2 plus angle 3 equals 180 degrees. Okay, so then if we do a little bit of algebra, since both left side of the equation are equal to 180, we can set them equal to each other. Whoops. Ooh, subtract angle 2 from both sides, and we have angle 1 is equal to angle 3. Woo! What does that prove? It proves exactly what Corey told us earlier, that the vertical angles are congruent. So let's go back to this slide. You might want to put a note on that one, that the vertical angles are always congruent to each other. Angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Then on that bad boy, you want to make a statement that linear pairs always add up to 180 degrees. We'll use that for some calculations in the next slide. So, using our vast stores of angle knowledge now, let's solve that problem. It is currently 9:14. At 9:22, we will reconvene. At 9:22, I would like 2 things to happen. 1, I would like you to take a break. And number 2, I'd like you to solve that problem. Don't be bashful about busting out your calculators. Questions about the instructions? Hot diggity. No, when you're good. Hold on, everybody. You're good? Okay. So I lied, it's 9:15. So we'll go until 23. Okay? Twink, discard, come over here, hit this, let's pause that. Krish, what do you got?
3x equals 27 over 4.
Hold please. Anybody else, 27 over 4? Yes, thank you.
And CAT equals 88 degrees.
CAT equals 88. How did you get CAT being 88?
Angle CAT.
Yeah, I gotcha.
So first I did C equals T, so 12x plus 7 equals 16x minus 20.
Okay. So 16x minus 20 equals 12x plus 7. Based on what, well, let me ask you, Krish, what kind of angles are those?
Acute.
No. What pair of angles are those?
Great. Linear.
Nope. This angle and this angle are what kind of angles?
Vertical angle.
Good. And what did Corey tell us about vertical angles?
They're equal to.
Bingo. Okay, so you did math, and got 27/4. Right?
Yeah.
Good. Now what?
Then I plugged it in into either. You can plug it into either one.
Which one did you plug it into?
I plugged it into 12x plus 7.
Okay, and when you do that, it turns out to be how big?
81 plus 7, so 88.
88. Good. I could have done that in my head. Okay, so therefore, what's the answer to this?
88.
No. Hold on. How many people agree with the 88 for this angle down here? Raise your hand. Okay, good. So I will tell you that this is not 88 degrees. How big is this angle? Gesundheit. Gesundheit.
Thank you.
You're welcome. Anybody else? Maddie?
Will all the angles together have to equal 360?
That's one approach to it. Go ahead, keep talking.
So then.
Hold on, Martha, I see you.
So then you can multiply 88 by 2 because.
176.
176, yeah.
Did that in my head.
And then you can subtract 176 from 360.
Mm-hmm. 184.
Yep. And then divide that by 2.
And get this angle to be
92 degrees.
92 degrees. Martha, what were you going to say?
I was gonna say that like this half S equal 180.
Oh, nice.
So
Oh, hold on, Martha. Question for you. What kind of angles, what pair of angles are these two angles here and here? They're not vertical.
linear.
Good, they're a linear pair. And we know, again, from what Corey told us, that a linear pair adds up to 180, so 180 minus 88. Is Maddie's method wrong? No. Just an alternative approach. Okay, does anybody see any problems with any of those answers? Brian?
Angle CAT is 92 degrees, but I see the angle looks like it's acute.
Uh-huh.
And I wasn't sure.
Yeah, that caused some discrepancy amongst many groups. Yeah. How do we handle that? Well, one of two things happened. I screwed up, or you screwed up. Which one happened?
You.
I screwed up, correct. The picture's drawn wrong. So in the future, what do? Do you trust the numbers or do you trust the picture? Always, always, always trust the numbers. All these calculations are perfect. My diagram is incorrect. Oh, I don't know, maybe I drew it wrong, purposely. or not. Let's move on. Fourth pair of angles, supplementary. Simply two angles that add up to 180 degrees. Okay. While you're writing, we've talked about the golden retriever relationship in dogs, right? This is where I need some audience participation. Okay, how does it work? Are all golden retrievers dogs? Are all dogs golden retrievers? No. Okay, so supplementary angles add up to 180 degrees. Are all linear pairs supplementary? Yes. Are all supplementary angles linear pairs? No. Okay, good. Supplementary just means they have to add up to 180. They don't have to be next to each other. They don't have to be even in the same continent. A 1 degree angle, any 1 degree angle is going to be supplementary to any 179 degree angle. And the last pair that we're going to talk about today are complementary angles. They add up to 90 degrees. Complementary adds up to 90. Supplementary adds up to 180 degrees. Very little of the work that I have you do is going to be regurgitating these facts. It's going to be applications like we did on the last problem involving angles CAT. So therefore, we're going to end today with a couple more of those calculations. When you're ready. Are you ready?
No.
How about now?
No.
Now? How about now?
No.
No? Yet? You got it now? Good to go? We getting warmer?
No.
Right there. Sounds so hostile, Mickey. No! How about now?
No.
No? Okay, now you're good to go, right?
Yeah.
Oh, thank goodness. Everybody else good to go?
Yeah.
The hostility level continues to increase.
How about now? Nope. Yeah, yeah, no, still a no. And now? Okay then. Let's try that one first. All I want you to do is find x, and then find the measures of the angles. Oh, by the way, Madeline, how many angles in that picture? Oh, very nice. Good. 3 angles in that picture. Carry on. While you're solving, ask yourself, self, what kind of angles are those? What pair of angles are those? That will help you solve the problem. I'm sorry, what?
Okay, let's just get a bit of
Yeah, yeah, I do.
I got 30. I am No, because both of those added together equal 1 equal. It's not the other one. They are equal to each other.
That's so confusing.
No.
They're what's it called? Supplementary angles. That's what they are.
Do you add them?
Yes. That's equal to 180 again. Because that's what they are. But I should equal to 180. And then these X you get 13 and then you plug it back into 180. And then that's how you get the.
Wait, you did it right. Come on, just had all for one.
Oh, it's minus 32.
You did it right. You just have to do it right. You're not making you guys.
Oh, they're supplementary.
I don't think for X, for H,
There's one, say that, 180. They're supplementary.
What I did was I set.
Oh my god.
So 10x minus 5
Very nice,
plus
Sarah.
plus x equals
Get something, you gotta write the equation first. You don't have an equation, you just have a statement. What'd you get for X?
I know,
Try to stay below that, because I got another problem that takes on the other half. Right, hopefully you're correct.
I think I did this right.
That was mine.
Uh,
52.
yeah. Evil.
It's because like when you do basic and you do the main for the and then it comes down. I can
Yeah. X, angle 1, angle 2. We can go.
just say that equal to 180. Right there, it's gonna get the atom. I would do
Third angles. Let's see what Ryan gets. So far, so good. Same.
This is tiring.
It'll be over in 20 minutes.
I mean, like, it's just accident.
Well, less.
It's not.
I actually need to go
Play video games.
Alright, you're good. Thank you, Ryan. That's it. Good. Stick it to the front of the board. Over on the left. No, the left. Left. There you go. Right there. Bingo. Okay, so Ryan solved the problem. Walking around the room, it seemed that a number of people had the same answers and agree with him. Ryan, could you tell us what you did? I mean, we can all read and everything, but we'd like to hear you tell us the story.
So since both the angles add up to get a straight angle at the
Uh-huh.
bottom,
Oh, can I interrupt for a second? What pair of angles are those two angles?
angle HIK and KIJ.
Correct, and what pair of angles do they form?
Oh, they're supplementary.
Good, they're also,
They're adjacent.
good, and they're also,
I don't know the last one.
linear pair. Is that what you were gonna say, Martha? Good job. Yep, all right, back to you, sir.
So since the straight angle is equal to 180 degrees, we can write out 10x minus 5 plus 4x plus 3 is equal to 180. And then I ended up adding them together and get 14x minus 2 equals 180. Add 2 to both sides. 14x is equal to 182. And then you divide 182 by 14 and get x equals 13.
Perfect, did math, x equals 13. Love it.
Okay. Then I plug in x for 4x plus 3, and I ended up getting 55. And then to get the other angle, since they add up to 180, you can subtract 55 from 180 and get 125.
Perfect. You could have also plugged 13 into the other angle, but you'll get the same answer. Excellent. Let's give it up for Ryan, please. Thank you, Ryan. Okay, I have another problem for you. After I erase. Erasing. I think I'll leave that dot there to torture 6th period. Okay, doke. Solve that one.
Just execute. I finished. It's 60 and 30.
Can't put your hand on the board.
Ugh.
You want to change it to a different color too, or are you okay with blue?
I'll do black.
Okay. There you go.
Oh, this one.
There's no letters on this one. What angle 1,
It's about 35 knots.
Yeah, you're right. Cold and flu season?
Yep.
Okay.
No, allergies.
Allergies. Oh, I wouldn't want that sign, but I hear it's flu. Especially wearing a mask. Just say that for later.
Wait, hold on.
Sarah, where are you going?
Oh, never mind. No, I
Finish
didn't.
the problem.
Wait.
Sarah.
I did it wrong.
No, you didn't.
Yeah, because I did.
No, you didn't solve the problem.
Is it minus 90 minus 3 is 87.
Correct.
I put 86.
Crazy.
I just went.
You're okay now?
Yeah, I'm
Good.
fine.
I worried about you there for a second, but
Thanks.
you're back. We'll talk about that. Perfect. Thank you, Sarah. Okay, so a couple of people asked me, well, wait, the angles aren't labeled. What are we going to do? Well, you have a couple options. Label it. Okay. W-A-S-P. There we go. Or put a 1 down here, put a 2 down there. Talk about angle 1 and angle 2. It's entirely up to you. Or that top angle and that bottom angle. Sarah, what kind of angles are those two?
Adjacent.
Good. What else are they?
Complementary.
Outstanding. Any others? No. Good. So what did you do?
I like added them together, so 2x plus 2 plus x plus 1 equals 90.
Uh-huh.
Because 90.
Yep.
And then I added all that together to get 3x plus 3 equals 90, subtracted 3 from both sides, and then divided the 87.
Did math. X equals 29.
Yeah,
Hot
and then
diggity.
put the x back in to the equation.
1630. Now, when you put the x back in, if you get two numbers that don't add up to 90, that would be an indicator that you screwed up somewhere. So, when you remember when Ryan did the problem, he took his answer and subtracted one from 180. No problem there. She could have taken the 60 and subtracted from 90 to get 30. I would suggest, however, that you plug it back in just to make sure the numbers add up and you didn't make a math error. Okay? Lovely. Let's give it up for Sarah. See done? Golf clap. Okay, this one gets a little nasty, so I'm going to take you through this gingerly, and then we'll end with this today. So this is a problem that doesn't give you a lot of information, where you have to build up information on your own. So if I have an angle X, hold on, let's start with something different. Let's start with a 5-degree angle. If I've got a 5-degree angle, we have a term called a complement. And a complement is the angle that, when added to 5 degrees, gives me 90 degrees. Therefore, what would be the complement of a 5-degree angle? Sam? 85 degrees. Good. Okay, so that's the complement. What would the supplement, Sam, of an what would the supplement of a 5-degree angle be?
175.
Good. Complement is the value that, when added to the original angle, gives you 90. Supplement is the value that, when added to the original angle, gives you 180. Are we good here before I move on? Because things are going to get a little weird in a second. Suppose instead of being 5... Oh, hold on. Sam, where'd the 85 come from?
90 minus 5.
Good. And where'd the 175 come from?
180 minus 5.
Perfect. So now, instead of 5 degrees... what if I tell you your angle is x degrees? How big would its complement be, Sam?
90 minus x.
Perfect. And how big would its supplement be?
180 minus x.
Beautiful. Is everybody clear on that? Good. If you understand those two ideas, then solving these problems is literally just a matter of writing down exactly what it says. Okay, and I'll take you through that in a second. Okay, so if our angle is x degrees, it says the measure of the supplement of the angle. Sam already told us that's 180 minus x. Is the same thing as equals. Is 60 less than. What mathematical function is less than? Addition, subtraction, multiplication, division. Subtraction. So we're going to subtract 60 from that. Less than 3 times the measure of the complement. 3 times the measure of the complement. Okay? That's the hard part in these problems. Solving them should be pretty easy. And I'm not going to go through that because I assume you can solve a linear equation. But again, if you write down exactly what it tells you, remembering that this is the complement and this is the supplement, you should be good to go. When I solve for x, I'll know the angle measure. If they ask you for the complement, take that answer, minus it from 90. If they ask you for the supplement, take that answer and subtract it from 180. Okay, you'll struggle with those a little bit, but we'll work through it tomorrow. Not tomorrow, I lied. Wednesday. Okay, we good? Last thing is, we talked about perpendicular already. We talked about the little box down in the corner. So this doesn't require much work, except I don't remember, did I give you that symbol? No? New symbol then, upside down capital T means perpendicular. So we don't have to write out that big scary word, perpendicular. Like I said earlier, we're mathematicians and we're lazy by nature. So we abbreviate everything or create a symbol for it, and that's a symbol for perpendicular. There are actually 4 90-degree angles here, but we only write one of them. Okay. Questions? All right, it's all about angles today. My advice for you, last piece of advice would be while you're solving the algebraic problems like we've done, start the problem by asking yourself, which pair of angles am I looking at? Are they just adjacent? Are they vertical? Are they a linear pair? Are they supplementary? Are they complementary? That'll help you write equations to solve for x and to answer the question. Not only should you be solving for x, but make sure you answer the question. Some problems will just say, solve for x. Others will say, solve for x and find the measure of angle, yada, 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 or blah, blah, blah. Okay. Good. We're going to skip this one. We are done.